Good morning, class. My name is Ahmed, and today I'm going to be talking to you about 5 trends in the periodic table. So, energy levels is a state in which the energy of a physical system is well defined by quantum mechanics. The trend in energy levels from going up to down increases, and that is because the number of energy levels in the electron cloud take up more space. Therefore, the trend within a group or family on the periodic table is that the atomic size increases with increasing number of energy levels. And going side to side, it stays the same, and that's because when you move across a period, you only add one valence electrons from one group to another, so you don't exceed the 8 valence electrons until you reach the noble gases, which already has a full outer shell. The second trend I'll be talking about is ionization energy. Ionization energy is the energy required to remove an electron from an atom or an ion. As you move down a group, the ionization energy decreases. And that is because each element has more occupied energy levels than the one above it has. And as you move down a group, each successive element contains more electrons in the energy levels between the nucleus and the outermost electrons. And this electron shielding causes the outermost electrons to be held less tightly to the nucleus. And as you move from side to side, the ionization energy increases. And that is because as you move across a period, the number of protons and electrons increases. The increasing number of protons increases the nuclear charge, causing more attraction to the outer electrons. Thus, more energy is required to remove an electron because the attractive force on them is higher. Atom in a chemical compound to attract electrons. As you move down a group, electronegativity decreases. And that is because from one element to the next one in a group, the principal quantum number increases by 1, so another principal energy level is occupied. The more protons an atom has, the more strongly it should attract an electron. Therefore, you might expect that electronegativity increases as you move down a group. However, electron shielding plays a role again. Even though cesium has many more protons than lithium does, the effective nuclear charge acting on the outermost electron is almost the same in both atoms. But the distance between cesium's 6th principal energy level and its nucleus is greater than the distance between lithium's 3rd principal energy level and its nucleus. This greater distance means that the nucleus of a cesium atom cannot attract a valence electron as easily as a lithium nucleus can. Because cesium does not attract an outer electron as strongly as lithium, it has a smaller electronegativity value. As you move across the period, the electronegativity increases. And that is because of the increasing number of protons. The effective nuclear charge increases across a period because of the increasing number of protons, and as this increases, electrons are attracted much more strongly, resulting in the increase in electronegativity. And for the fourth trend, atomic radius. One way to measure the size of an atom is by calculating the bond radius, which is half the distance from center to center of two like atoms that are bonded together. As you move down the periodic table, atomic radius increases. And as you move down a group, another energy level is filled, thus increasing the size of the atom. The electron shielding also plays a role with the outermost electrons, making them not pulled closer to the nucleus. And from moving side to side, atomic radius decreases. As you move from left to right, all additional electrons go into the same principal energy level. As a result, electron shielding does not play a role. The increasing nuclear charge pulls the outermost electrons closer to the nucleus, thus reduces the size. The fifth and last trend is reactivity. Reactivity is the tendency of a substance to undergo chemical reaction either by itself or with other elements, and to release energy. Going down a group, as you can see, reactivity increases. And that is because as you go down the group, the valence electron is further from the nucleus, which means it's easier to lose, which makes it more reactive. Going side to side, the reactivity decreases. And that is because you have more valence electrons to lose, or to gain, you need to gain more valence electrons. But when you reach group 17, you only need one more valence electron to gain, which makes it reactive. As a conclusion, group 1 and group 17 are the most reactive, and the others are less reactive than them. And noble gases aren't reactive because they have a full outermost shell. Thank you for watching. I hope you enjoyed this video.